Hi, we're working on intermediate algebra. This is section 6.4. We're going to do the word problems here. Example 5 starts on page 235. All right, solve using quadratic formula. So using the quadratic formula is the topic for this section. So we're going to solve these with quadratic formula. The area of a rectangular flyer advertising Osceola Math Fair is 22 square inches. The length of the flyer is 2 inches more than the width. What are the length and width of the flyer? So the first thing we need to do is define what kind of information we have. We have the area of the flyer being 22 inches. We know that the length is 2 inches more than the width, so that will be the width plus 2. And there's another piece of information that we need that's not in the question, and that is the formula for area of a rectangle, which is length times width. Once we have our information, then we're going to substitute this 22 instead of A, and we're going to substitute W plus 2 instead of L, and this will then turn into our equation. So once we do that, we end up with an equation that says 22 equals W plus 2 times width. So again, I started with this area equals length times width. I put the 22 in instead of area, and I put W plus 2 in instead of length. And of course you have to use a parentheses around that so that the whole thing gets multiplied times this W. Now you have this equation that you can solve for width. We're going to start by distributing here. So when we distribute that, we're going to have W squared plus 2W. Just by distributing this, we get W squared plus 2W. And now we recognize, because of this square here, that this is a quadratic equation, not a linear equation. So the only way, we have actually several different ways to solve a quadratic equation. The most preferable is by factoring. To factor this, though, we need to make it equal 0. And once you do that, you do realize that it doesn't factor, because there are no factors of negative 22 that add to make 2. So this doesn't factor. So we're going to go with what the directions say, use quadratic formula. In order to use quadratic formula, all the terms have to be on the same side, and it has to equal 0. So that 22 is going to go to the other side, and we're going to have a 0 equals W squared plus 2W minus 22. If you like to write it the other way, W squared plus 2W minus 22 equals 0. It does not matter which side your 0 is on. They're equal. They mean the same thing. Now, since we're going to use quadratic formula, we need to state what the formula is. So we're going to do that over here. X equals negative b plus minus the square root of b squared minus 4ac all over 2a. And we need to define a, b, and c. And remember, a, b, and c are the coefficients of your terms once you have them in descending order and equals 0. So a will be 1, b will be 2, and c will be negative 22. All right, one other thing I do want to talk about here is I wrote this x equals, this is generic. We aren't actually solving for x. Since our variable here is w, we really should have a w here, not an x. So let's cross out x and say that this is going to be w. And then we're going to substitute in a, b, and c into our equation. I'm going to zoom out a little bit here. Okay. So w equals negative b, so negative 2, plus minus the square root of b squared, 2 squared, minus 4 times a times c all over 2 times a. And then we just start simplifying. So do not forget that this negative sign here always comes down. If b is positive, you only have the one negative sign, but if b is negative, you'll end up with 2 negative signs here. So watch those signs. Plus minus, okay, 2 squared is 4. And then I look at these signs here. I have a negative times a positive times a negative makes positive, so this will be plus. And then I have 4 times 1, which of course is 4. and 4 times 22 is 88. So I don't need all of this, but that's not going to erase, so it's okay. Over 2 times 1, which is 2. Still simplifying. Just continue to simplify as much as you can. Negative 2 plus minus the square root of 92, 4 plus 88 over 2. Okay, 92 is not a perfect square. If we were just working a pure math question, we would simplify this as much as possible and leave the radical in. But since this is a word problem, we really need to know the width of this rectangle. So we're going to estimate this as a decimal. At this point with the word problems, you can put 92 into your calculator and get a decimal for it. I believe that decimal comes out to be not approximately 9.59, something like that. So we have negative 2 plus 9 minus 9.59 over 2. And I would suggest that you keep or round to 2 decimals when you do this with a radical. Round to 2 decimals. Okay, at this point, we actually have 2 answers here. We do need to simplify this as a plus and a minus. So we're going to take this negative 2 plus 9.59 over 2 and negative 2 minus 9.59 over 2, and we'll simplify them individually. This one comes out to be about 3.8, and this one comes out to be negative 5.8. And of course, you're just going to put that in your calculator. All right, don't forget though, these are opposite signs, so this is subtract and then divide by 2. These are same signs, so this is add, but it'll stay negative and divide by 2. And you end up with these 2 numbers here, 3.8 and negative 5.8. Well, we're talking about the width of a rectangle. The width cannot be negative, so we will reject the negative, and our width will come out to be 3.8 inches. We are not done though, because if we scroll all the way back up, we can see in the question it says, what are the length and width of the flyer? We found the width to be 3.8 inches. How are we going to find the length? You're going to go back here to this information. The length is the width plus 2. So we can go down here and rewrite that again. The length equals the width plus 2. We're going to take our value that we found for width, 3.8. We're going to add 2, and we're going to get 5.8. And don't forget, when you're working this, you need to express these in a complete sentence, or answer the question in a complete sentence. So that sentence will say the length is 5.8 inches from here, and the width is 3.8 inches from here. All right, example 6. Solve using quadratic formula. This is on the bottom of page 236. After the discussion of quadratic functions in class, Madeline's eager to practice what she learned. She goes to the last floor of building 4 of the Osceola campus and throws an object up in the air. The function that models this scenario is given by h of t equals negative 16t squared plus 32t plus 92, where h of t is the height of the object above the ground and t is the time in seconds. She wants to find out when will the object hit the ground. So we're going to be solving for t, which is time. The object is hitting the ground. So that means that we're going to use this function, h of t equals negative 16 t squared plus 32t plus 92, where h is the height of the object above the ground, or how far did the object fall, really. Oh, actually, no. The height of the object above the ground means when we're looking at the time. T is the time in seconds to find out when the object will hit the ground. Okay, so the height is going to be 0 because the object is hitting the ground. So we're going to put a 0 there. And we recognize this as a quadratic equation because of that t squared there. This t squared here. Now, this does factor a little bit. there's a GCF here of -4. If there's no variables in your GCF, it doesn't affect your solution. It will just make quadratic formula easier if we can make these numbers smaller. So we are going to factor out a GCF of -4. That leaves us with 4t squared minus 8t minus 23. And these signs are different here because when you factor out a negative, it changes your signs here. In other words, this -4 times this 4 gives us -16. -4 times -8 gives us +32. -4 times -23 gives us 92. When you factor out a negative GCF, the signs change. So now we have this trinomial here, and we can assign A, B, and C from this trinomial. This -4 is not going to affect our solutions. So let's write our quadratic formula. We're going to be solving for t this time. -b plus minus the square root of b squared minus 4ac over 2a. A is 4, b is -8, c is -23. And we're going to substitute these into the formula, solving for t. So -b, and in this case we do have both negatives. This first one is always there. This one is coming from b being negative. Plus minus the square root of -8 squared minus 4 times 4 times -23. And the parentheses are your friend here. Over 2 times 4. Now just simplifying. That double negatives, those double negatives there simplify to make a +8. -8 squared is 64. And then we look at these signs to see if this is going to be a plus or a minus here. Negative times positive times negative makes positive. So this will be plus 4 times 4 is 16. 16 times 23 is 368. You can use your calculator for that. Over 8. So 8 plus minus the square root of 432 over 8. And again, if this was a pure math question, we would just simplify this and leave the radical in. I don't believe this is not a perfect square. But since this is a word problem and we're solving for time, we're going to change this to a decimal. You'll be wasting your time to try and simplify it mathematically or algebraically. Just put it in your calculator, turn it into a decimal if you're working a word problem. So that's going to turn into 8 plus minus 20.78. That's what that decimal is, keeping 2 decimals, over 8. And now this is the point where we need to separate this plus and minus, and we're going to turn this into 2 statements. One of them's plus, the other one's minus. So it will be 8 plus 20.78 over 8 and 8 minus 20.78 over 8. That's what this plus minus turns into. And of course, just put it in your calculator. This is an add because they're the same signs here. When you put this in your calculator, it turns out to be approximately 3.6. This one, though, because this is a positive and this is a negative, this one turns into a negative divided by a positive, which is negative 1.6. All right, we're solving for time, t. Right? Yes, we're solving for time. So when you're solving for time, you can't have negative time. You can reject this negative. So this is your time, 3.6. We're going to answer the question in a complete sentence. The question was, she wants to find out when will the object hit the ground. The object will hit the ground in approximately or about 3.6 seconds. Using the word about just lets us know that you did round this so that it is approximately 3.6 seconds. All right, example 7, solve using quadratic formula. This example is on page 237. Intramural sports at Valencia College gives students the opportunity to be active. On Osceola campus, soccer is one of the intramural sports available to students. During one of the practice sessions, one of the students, Sienna, kicked the soccer ball straight up from the ground with an initial velocity of 48 feet per second. Its height above the ground in feet is given by h of t equals negative 16t squared plus 48t. When will the ball reach a height of 24 feet? So again, a quadratic equation here, or a function, h of t equals negative 16 t squared plus 48, where t is the time in seconds, again, and h is the height of the ball above the ground. This time we are not trying to find out when will the ball hit the ground. We're trying to find out when the ball will reach a height of 24 feet. So this height is now going to be 24. So we're going to replace the h with 24, and we're going to be solving for t. So when we solve using quadratic formula, we have to have this equal to 0. So this 24, the first step is to take this 24 to the other side. So that would give us negative 16t squared plus 48 minus 24 equals 0. I hope you're not confused because I did switch the sides. I first mentally took this over here to make it a negative 24, and then I flipped and put the 0 over here just because people like to usually look at this way. It doesn't really matter if you put the 0 on the left or the right. As long as you have these signs correct, it's fine. All right, do we have a GCF we can get rid of? It looks like there's a GCF of negative 8 here. So factoring out the GCF makes quadratic formula easier because you can then use smaller coefficients. All right, it looks like I wrote this wrong, so I'm going to go back. This 48 should have a t on it, shouldn't it? So therefore this 6 should also have a t on it. All right, again, when you factor out a negative here, it does change these signs here. So negative 8 times 2 is negative 16. Negative 8 times negative 6 is positive 48. Negative 8 times positive 3 is negative 24. So it will change these signs when you factor out a negative GCF. Now we're going to write the quadratic formula and assign a, b, and c. So we'll be solving for t. Negative b plus minus the square root of b squared minus 4ac, that's an a, over 2a. And a is 2, b is negative 6, c is 3. Again, when you factor out a GCF, as long as there's no variable in your GCF, it does not affect a, b, and c. This is still a, b, and c. It won't affect your solutions after all that. It just makes a, b, and c smaller, and therefore the quadratic formula a little bit easier to manage. So this is perfectly fine. A, b, and c. And now we're going to substitute them in. So negative b, again with the double negatives, b squared minus 4 times a times c over 2 times a. Simplifying, these double negatives here make a positive 6. 6 squared is 36. Negative times positive makes negative. 4 times 2 times 3 is 24. Over 2 times 2 is 4. Continuing to simplify, 6 plus minus the square root of 12 over 4. And again, at this point, since this is a word problem, we're just going to change the square root of 12 to a decimal. That's going to give us 6 plus minus the square root of 3. Oh, I'm sorry, it's not a square root anymore. It'll be 3.46 over 4. Split this plus minus into two different expressions, one with plus, the other with minus, and you have 6 plus 3.46 over 4 and 6 minus 3.46 over 4. And you could put both of those into your calculator. They turn out to be 2.37 and 0.64. So this is a little bit different than the previous examples. In the last two examples, when we split these, one turned out to be positive and the other one negative, and we could disregard the negative because it didn't fit into a word problem. This time they're both positive. So they are both valid answers, but why? If you remember the story, Sienna was kicking the ball straight up from the ground. And when you kick a ball straight up from the ground, let's see, maybe a picture. So if this is Sienna and she kicks the ball straight up from the ground, the ball is going to go up and it's also going to come down. So we were being asked to find out when will the ball be at 24 feet. If this is 24 feet, there's actually 2 times the ball hits 24 feet. Once on the way up, and then it will peak, and then again on the way down. Of course, the smaller of the 2 numbers will be on the way up, because that happens first, and then the larger is on the way down. So in 0.64 seconds, the ball will go through 24 feet, but then again in 2.37 seconds, the ball comes back down through 24 feet. So these are both valid answers based on the question, when will the ball be at 24 feet? So we will use both of them when we write our sentence. The ball will be at 24 feet in 0.64 seconds, and again in 2.37 seconds. All right, example 8 is on the bottom of page 238. It says solve using the quadratic formula. The product of 2 consecutive positive even integers is 624. Find the 2 integers. All right, so we have 2 consecutive positive even integers. So we're going to set up our variables first. The first integer is going to be x. The next one, if it's consecutive, it would be x plus 1. It would be the next one after x. But since they're both even, it won't be plus 1. It will be plus 2. And just a little bit of clarity there. If x is an even number, the next consecutive even number is 2 away. So the first even number I'm talking about will just be x. I don't know what it is, but the next consecutive even number will be 2 more than that, or 2 away. So this will be x and x plus 2. The product of them means they're going to be multiplied. So if I multiply my 2 numbers, x and x plus 2, this will be their product. The question says the product of 2 consecutive positive even integers is 624. So I know that when I multiply those 2 numbers, their result should be 624. And this turns out to be the equation that you're going to try to solve for x. First, we're going to simplify it by distributing this x. So that gives us x squared plus 2x equals 624. And then, of course, we recognize this as a quadratic equation. We're going to solve it using the quadratic formula. So this 624 needs to go on this side so it can equal 0. So x squared plus 2x minus 624 equals 0. Turns out that this will factor, you guys, but we're going to use the quadratic formula because that's what the directions said. It would have been faster to factor it, but the directions say to use the quadratic formula. So we're going to write our quadratic formula. X equals negative b plus minus the square root of b squared minus 4ac over 2a. A is 1, b is 2, c is negative 624. Of course, that's based on this coefficient, and this coefficient. So now we're going to plug it in. Negative b plus minus the square root of b squared minus 4ac over 2a. Simplifying, we have negative 2 plus minus the square root of 2 squared is 4. Then I have negative times negative makes positive. 4 times 1 is 4. 4 times 624 is 2,496 over 2. So negative 2 plus minus the square root of 2,500 over 2. And you could put that 2,500 into your calculator, or you might know already that's a perfect square. The square root is 50. And this is the point where we need to separate this plus minus. So we're going to end up with negative 2 plus 50 over 2 and negative 2 minus 50 over 2. That's what this plus minus gives you. So this is 48 over 2, or 24, and this is negative 52 over 2, negative 26. Now, if you recall, can I scroll all the way back? If you recall, the question said the product of two consecutive positive even integers, and our solution gave us one positive and one negative. So since we're only looking for positive integers, we can discount this negative solution here. So we're just going to ignore that one. This is x. Remember at the top we defined our two integers as x and x plus 2. Well, it turns out that x equals 24. What is the other integer? X plus 2. So the other one will be 26. So these are the two integers.